Atoms are the building blocks of matter. They consist of a nucleus and orbiting electrons. The nucleus contains protons, which have a positive charge, and neutrons, which have no charge. Electrons carry a negative charge. Electric charge is a fundamental property of matter. It comes in two types, positive and negative. Objects with like charges repel each other, while objects with opposite charges attract. The SI unit of charge is the coulomb, abbreviated as C. 1 coulomb is a very large unit of charge. In most everyday situations we deal with smaller units like microcoulombs or nanocoulombs. Electric charge is quantized, meaning it exists in discrete values. The smallest unit of charge is the elementary charge, which is the charge of a proton or the negative of the charge of an electron. Coulomb's law describes the force between two-point charges. It states that the force is directly proportional to the product of the charges, and inversely proportional to the square of the distance between them. The force is attractive for opposite charges, and repulsive for like charges. The constant of proportionality is called the Coulomb constant, often represented as K. An electric field is a region around a charged object where it exerts an electrostatic force on other charges. The electric field at a point is defined as the force per unit charge experienced by a small positive test charge placed at that point. Electric field lines are a visual representation of the electric field. They originate on positive charges and terminate on negative charges. The density of field lines indicates the strength of the electric field. An electric dipole consists of two equal and opposite charges separated by a small distance. It is characterized by its dipole moment, abbreviated as P, which is the product of the magnitude of one of the charges and the distance between them. The electric field due to a dipole is different from that of a single charge. It falls off more rapidly with distance. The dipole moment points from the negative charge to the positive charge. When a dipole is placed in a uniform electric field, it experiences a torque that tends to align it with the field. The magnitude of the torque is proportional to the dipole moment and the sine of the angle between the dipole moment and the electric field. Gauss's law relates the electric flux through a closed surface to the total charge enclosed within the surface. The electric flux is a measure of the number of electric field lines passing through a surface. Gauss's law is a powerful tool for calculating electric fields in situations with high symmetry. It states that the total electric flux through any closed surface is proportional to the total charge enclosed within the surface. Permittivity is a measure of a material's ability to store electrical energy. It is a constant that relates the electric field to the electric displacement field in a material. The superposition principle states that the total electric field at a point due to multiple charges is the vector sum of the electric fields due to each individual charge. This principle allows us to calculate the electric field due to complex charge distributions.